Today we're going to study density. Density is a measure of how tightly packed that object is. So if you ever throw a paper ball or snowball, you know that the more you pack them up together, the denser the object is. The density is a measure of mass of the object over its volume. So what does that mean? The equation for density is basically mass divided by volume. Because of that, the unit is mass unit per volume unit. So if you look here, you will see that it's either gram per milliliter, kilogram per milliliter, kilogram per liter. You can also have cm cube, which is mean gram per cm cubes, kilogram per cm cubes, and so on. Mass. Mass is the measure of the amount of substance, amount of matter in the object. So think about it's like heaviness, but then again, you will see that mass and weight are two different things. Especially when you go to physics. Mass is how much stuff that you have inside the object, and weight is the mass time the effect of gravity. So the running joke was if you want to lose weight, you want to go on the moon, right? Because in the moon, gravity is less, so you'll feel weightless, but you suddenly, you certainly still have the same amount of matter, uh, at least initially when you go to the moon from Earth. You still should have the same amount of mass initially, and your weight will change because of the gravity, right? But in chemistry, most of the stuff that we're talking about is all on Earth and done in the same environment. So in this case, the effect of weight or the effect of gravity is not as much important for us. So pretty much mass can be understood at weight, but not so much, right? Not the same. So to measure the mass, you will use the following object. Usually you will have a digital balance in the classroom that you can use. Most lab places will have digital balances. Some places, some classroom, you might have triple beam balance. Those you have to measure by yourself. In the old time, you have a scales that you can put each individual weight on the one side, and the other side you put an object there, right? So again, you could have different type. All right, let's talk about volume. Volume is a quantity of space the object occupies. So for example, right now you guys are whether in your study tables, maybe just so far, right? So you occupy a space. So that will be a volume, basically. The space that you occupy, right? That's how much volume you have. Volume of the solid with the regular shapes can be usually measured with ruler and a user formula. So for example, behind the camera, you can see that there is a cube, so you can measure it with the ruler, and then you can see we have length with width, right? We measure height, and then we can use mathematical formula to figure out the volume of the object. So most volume of the object, as long as they are regular shape, you can measure it with using ruler. Volume of the shapes for the solid with the irregular shapes or liquid can be measured using something called graduated cylinder, which you can see here with a colorful cylinder. And we have either the glass or plastic, but in this case, you can see all of them are glass, and then they have a different size, different amount. All right, moving on. Okay, so before we get into the how do we measure the volume of irregular shape, I want to talk to you a little story about Archimedes principle. You probably heard about him as the guy running around the town naked, shouting "Eureka!" Right? So the story come about as is this: the king asks Archimedes or tests, give a test to Archimedes that tell him to figure out whether the crown that he made is either real gold or not. The king is very suspicious of goldsmith, right? Want to figure out whether the crown is real gold or not. And the test that the king said is you cannot destroy the crown. You cannot melt it right into like spear shape or cube shape to measure. You have to be the same that the shapes. So if you look here, you will see that crown is quite an irregular shape. It is really hard to measure out its volume. You can measure out its mass easily. Put it on the scales, you can tell, but the volume is a part where Archimedes was stuck. Because Archimedes said if he if he can figure out density, he can figure out whether the crown is made out of real gold or not. But he can't because he can't figure out the volume. So one day, Archimedes principle go to those public bathhouse back in the day, right? They don't. So he went to those, and he noticed that as he was getting in, the water was overflowing. The water level rise, and it was overflowing. And then he observes and he noticed that this is happening as people are going in to the bed, right? So into the water, and then so he then got an idea how to figure out the volume of the crown, and he's running around the town saying Eureka. So let's talk about how did Archimedes make that sense. This is what Archimedes discovered when he was going into bed house, right? So he discovered that when the object is put in the water, the object will displace the water the same amount of its volume at whatever the volume of the object. So in this case, you can see in here, example, initial level of water in this graduated cylinder is 60 milliliter. And then when you put in the rock, the volume increases and now it's in 90 milliliter. So you can see the volume change by 30 milliliter. So therefore, here is the Archimedes principles. The volume of the rock is basically the volume of the water after adding the rock minus the volume of the water before adding the rock. So again, right, object with the water minus the object without the object, right, water. And final minus initials, if you think about that. Okay, so basically we got 30 milliliters, so we said that the rock must occupy 30 milliliter. The next one is density equation. So earlier I showed you that density is d equal to m over v, but you can see that d equal to m over v can be changed into write the other equation. So in this case, you can see that the purple arrow, which indicate I can switch the v and the d over. So notice that there's equal sign in between. If there's equal sign in between, the variable on the bottom of one equation can be switched with variable on the top of the equation of another bottom. Right? If you think about it, underneath that d is actually you have 1 over. So you can see that just pretty much move over. Okay, so you can think about like that. The next one, you can simply switch the v and d over, right? So I can just simply switch it. So, and then you can get this as d equal to m over v again, right? Or I can just send that d onto this side, and then which I can get m equal to d times v. So you don't necessarily have to remember all the equations, because once you know one, right, d equal to m over v, you should be able to write the rest of them, okay? So that's what it is. Okay, so here is a question. If you think you know how to solve for it, you can pause for the videos, and then you can try it, right? The equations that you can use are in this slides. So again, I'm going back. You can take a pause, and then you can figure out. All right, so hopefully you got the answer to this. Let's check for your answer. So this is what it is. Again, this is just the way for me to organize the information given to you. Do you have to write it like this for the test? Not necessarily, okay? So in fact, most of the time we did the test, we don't even write the given. We just kind of start with the equations, and then we start calculating, and then we write units. So for what I'm saying is, is on the test, right? We're expecting to see this part on the test, okay? So I'm not expecting the chart and everything, but I'm expecting the work and the answers, okay? All right, let's try another one. Again, pause the video and then try them. This time we're looking for mass. All right, let's check your answer. Did you get these answers? Were you off a little bit? Okay, if your answer doesn't match, chances are you pick up the wrong volume. So you can see here what I mean by wrong volume is that your volume is in liter. This is in milliliter. So you got to solve it to make it the same. So if you look here, I did switch it. Now it's in milliliter. So milliliter, they match. Okay, so you got to change that 7 liter into 7,000 milliliter. Then it will be okay. So you would do that and then you would solve for it. Okay. So hopefully you get that. Okay, going over, next one. Go ahead and try that one. Same thing as I tricky like last time. Okay, make sure you check for unit. All right, so let's go and check your answers. Hopefully this is what you get. Now notice you got to change the unit to make sure that unit match so that you can solve for it. And then when you're done, you are actually getting milliliter because your density is in milliliter. And you need to make sure that you swap it to the liter. Okay, milliliter, liter is 1,000. So we're simply dividing by 1,000, meaning you're moving 3 decimal place that other way, right? So you should know how to solve for that. Okay, the next one is a density simulation. Let me go ahead and show you what it is. Okay, so you have a block. We have different type of block. The good things about it is you can randomize it and then change the block size, change the material, for example, gold, right? So we can randomize this, and I think we can get like, I thought we can get a bigger size. Gold. Yeah, okay, wait, maybe. I'm not sure. So we have gold, right? So you can see before volume, after volume. So you're gonna subtract that. You can find the volume of the gold. Mass, just drop it. You got a mass of the gold. Right, same thing. Unknown object, mass, and volume. Right. So next part is this. This is the fluid density. You can see that as fluid density increase, the block now is floating. So as fluid density decrease, the block is sinking. So what does that mean? That means, right, the block density is more dense than the fluid number. In this case, it's floating, it will be less dense. So let me make it more. So the block density is probably around this fluid density. If you think about it, 3.13, maybe a little bit more, a little bit less, right? Again, this is where it is, but to know for sure, you can tell by measuring the mass, figure out the volume. So that's 25.5, 31.2. So you're going to say 31.2 minus 25.5. That will be milliliter. And then you're going to have the mass. So mass divided by what you found the milliliter, you're going to get your density. So that's how you're going to find them. In class, when you're doing the labs, that's how pretty much you find the density of these. You're just simply placing one in the scales to figure out the mass, and then places in the graduated cylinder to figure out the volume. Okay, so that is for the end of the density.